Hi everybody, sorry once again that I have to be away this week, but it's unavoidable, so I just recorded a quick little lesson for you guys where we'll do something with squares and square roots that we haven't done yet. We'll figure out where they fit in order of operations. So my guest teacher should have handed you out a little handout where this is the title. And what we're going to do is we're going to get you to do the notes and examples on this page as I go through these notes. Now, the first thing I'm going to do is just write something down just as a reminder to you. You should know this already from grade 6 and 7. So as I write in blue here, you don't have to write this part down. When I pick up the black pen again, that means that you should be writing it down. But here in the blue pen, I'll just quickly remind you about the order of operations as you learned them back in grade 6 and 7. Usually we use this cute little word called BEDMAS to remind people that the order of operations for a calculation should be B for brackets first, so do whatever's inside a bracket first, then E for exponents. Now you guys don't have a lot of experience with what exponents are, but I can tell you that, for example, 4 squared, that squared is also called an exponent. And then after that, the D and the M, that's a D, sorry, that's terrible, D. The D and the M actually stand for, of course, divide and multiply. And that is all done in one step. You do not skip past a multiply to do a divide first just because D comes before M. In fact, the D and the M are at one step. Same with add and subtract. A and the S stand for addition and subtraction. So that kind of already gives away where squared fits in order of operation. It is an exponent. And just to give you your first example, here's where you should start writing now. The first example, I've made that kind of small on this screen, is 5 times 4 squared. So you already have that written down, but beside it or underneath it, you now realize that according to BEDMAS, the order would be do the exponent first and the multiply second. So I do not go 5 times 4 is 20 and then square the number 20. That would be wrong. I go 5 times, and I know that 4 squared is 4 times 4, which is 16. And the final answer for that is 5 times 16 is 80. So that's how I would solve that example. Please make sure you copy down the correct solution to that example. I'll give you a second. Seconds up. If anybody needs a question answered or a quick pause, you could get my guest teacher to pause the video at this point. Otherwise, let's move on to the next section on that handout, where it says often a squared number is part of a formula. For example, the area of a circle is pi times r squared, or pi times radius squared. In math, when there's no symbol between two things, we know for a fact that there's a multiply between them. You read this as the area of the circle is equal to pi times the radius squared. So the example I have for you to fill out is this picture here. So write down the formula. Area is pi times radius squared. And now I would plug in the radius number, which happens to be 4. That's what this number is. Diagram radius is the distance from the center to the edge of a circle. And now please notice I plugged it in with a bracket, but that's just to make my life easier. That bracket doesn't really need to be there. And this example is just like the last one. It's a number times 4 squared. And you have to ask yourself, well, according to BEDMAS, what happens first? Well, the thing that happens first is the squared, the exponent, then the multiply. So this is really pi times 16. And again, I'm just using a bracket here to show that I know that it's a multiply, because again, if there's nothing between this symbol and this bracket, I know that means multiply. So at this point, I would grab my scientific calculator. Sometimes these worksheets will say use 3.14 for pi, but look up above the smartboard and you can see the pi has a heck of a lot more decimals than just 3.14. And it's about time you realize that every scientific calculator has a pi button on it. There's mine. So there's pi times 16, get an answer. Now, I don't need all of these decimal places. After all, how accurately do I really want to measure the space inside a circle? So I would then write my final answer as, let me look at that again, 50 point, we'll round it to 27. so 50.27, and that would be centimeters squared. And if you need a second to try to do that multiply in your calculator to see if you can find the pi button on your calculator, again, my guest teacher could feel free to pause the video here for just a second while you look for that and see if you can get the same answer as me when you multiply this out. Actually, for real fun, see if you can actually, on your calculator, times pi times 4, and then hit your squared button. You should get, when you hit equals, the same answer as that, because the calculator knows order of operations. That's one of the things that makes it a scientific calculator. All right, if we're ready to move on, next comes square rooting a number. And the square root symbol can be treated either, that should be a line there, sorry, should be treated either as an exponent or as a bracket depending on the situation. So here's a few examples, and again, fill these in on your page the same time I do. I'm treating this and this as a bracket. I have to do what's inside this bracket, which is square root 16, then square root 25. I can't add the numbers together first. So I would simplify this as 4 plus 5, which is 9. Please notice if I tried to add these numbers first, I would not get a 9. I'd get the square root of 41, which is nowhere near 9. This is the correct way to solve this. Same thing here. I have to do the square root and then multiply the answer because bracket comes before multiply in BEDMAS. So the square root of 16 is 4, the square root of 25 is 5, the answer to this is 20. Please notice if I actually multiplied 16 by 25, which would be 400, this time I actually would get 20. Please notice this one, if I actually did multiply 16 by 25, I get 400. And if I square root 400, I get 20. Interesting. This one, the order mattered. If I tried to add these numbers together and then square root, I wouldn't get my correct answer. But on this one, order didn't matter. I could either square root first or multiply first. Interesting. For this last example, I would actually treat this, again, we just said this a minute ago, as 4 times the square root of 49. I know that that's what this symbol means. So that's going to be 4 times 7, which is 28. Once again, this time I could not times 4 by 49 and then hit my square root button. I would not get the number 28. Okay, I'll give you a sec to catch up to me. Seconds up. This example, the square root sign here is really acting like a bracket. I have to add those two numbers together first. I can't square root them first. So this time it would be 16 plus 25 is 41. And the square root of 41, as we know, is not going to be a whole number. I can use my calculator for this if I want. 41 square rooted. Where is square root on this thing? I can't remember where square root is, and this thing's blurry looking at it. There it is. Ha, there he is. 6.40. I'll round it there. 6.40. Makes sense. I know that this number is between 36 and 49, so the square root's going to be somewhere between 6 and 7. That's good enough for a rounded answer. This one, again, this square root sign behaves like a bracket, so I have to treat the inside as the calculation I do first. So I have to do this as 16 plus 100. Remember, multiply happens before add. And then that's going to be then the square root of 116. And again, I think I'll go to my calculator to help me with that. Whoops, did I close the calculator? Maybe I did. So the square root of 116 is 10.77, which again makes sense because I know that this number here is between 100 and 121, so the square root will be between 10 and 11. Okay, the rest of this booklet that was handed out is more of this order of operation stuff with squares and square roots in it that you can try. But before you do that, make sure that you're done the other stuff first. That's kind of for the people who are ready to move on. I already have homework online updated for the day, and here's what it looks like. Hold on a sec. Make that a bit bigger. Oops. Oh, no. There we go. So here's the plan for the rest of these 3 periods. Again, I'm sorry that I'm not here for a triple period, but that's the way it works. So the booklet has a link that you can see on the screen here in blue. And as you can see, it also says that you still have the old booklet from last time, and you have these textbook pages. I'll put a link for my homework online onto the desktop if my guest teacher would like to bring that up after this video. And then after that, after you've worked for maybe the rest of this period and all of the next period, I'm going to get my guest teacher to put on a really cool cartoon for you that I remember watching when I was your age, if not younger, and it is awesome. So enjoy the rest of the last couple periods, and we'll see you tomorrow.